We're now going to look at compound inequalities. This type of inequality in example 5 is called a sandwich inequality or a combined inequality. You usually recognize them right away because it has two different inequality signs already in it before you start. So it has something squished in between. And there are actually two ways you can solve this, and I'll probably go ahead and just show you both. One way is as long as the variables are isolated in the middle, and they are, do you guys see that? Yeah. I have 3x minus 7, and it's between 5 and 8. Not equal to 5, but equal to 8. As long as the variables are all in the middle, you can solve it just by leaving it hooked together and isolating the x in the middle. That only works as long as there are no variables out on the ends. What we can do then is treat it like a three-sided inequality and add 7 to all three sides. That will give you 12 is less than 3x, which is less than or equal to 15. And then to finally finish isolating the x, you could divide all three sides by 3. So divide by 3, divide by 3, divide by 3. That gives us 4 is less than x, which is less than or equal to 5. In words, tell me what x can be. Can it be 4? Can't be 4. Could it be 4.5? Yes. Could it be 4.2? Yes. Could it be 4.7? Could it be 5? Yes. Yes. So it could be everything in between 4 and 5, but not 4. But it could be 5. Got it? We all understand what that means. And then that's really easy to graph because you just draw a quick number line. And we'll put a parenthesis at 4, a bracket at 5, and shade what's in between. Parenthesis at 4, bracket at 5, and shade everything in between to indicate that those are the numbers that would make that inequality true. That is a compound inequality. You may have heard those referred to as and inequalities in the past. But when they're written together like that, squished together, they're called combined or sandwich inequalities. Now, how many of you, when you first learned to solve these, you didn't leave them hooked together, you took them apart into two different pieces? And that's okay as well. Because it's written combined, it is understood to be an and inequality, but you can take it apart, and I was going to show you guys how to do that so that you would know what to do no matter what you came up against. Now what we can do, just to solve it a different way, is we can take this piece of it and write that down. So we have 5 is less than 3x minus 7. And we can take this piece of it and write that down. 3x minus 7 is less than or equal to 8. And we can solve them both. So for the left side, you want to add 7 and divide by 3? Yeah. So we'll add 7. Divide by 3. So we end up with 4 is less than x. Another way of saying that is x has to be, you turn it around, x has to be greater than 4. Right. So you can turn that around. The other side, we add 7. Divide by 3. And we see that x has to be less than or equal to 5. Now you have to understand that this was presented to you as an and inequality. That means that both of these things have to be true at the same time. X has to be greater than 4, and x has to be less than or equal to 5. The only numbers that are going to satisfy that are the ones in between 4 and 5. Sometimes it helps to look at it on a graph this way when you've taken it apart like that. Mark 4, mark 5. We'll do parenthesis, greater than 4, bracket, less than or equal to 5, and then we can only keep where they overlap. That's what an and inequality has to do. They have to overlap. So the overlap occurs from here to here. And no matter which way we solve it, what's our final answer? Give it to me in interval notation. Parentheses. 4, 5 bracket. If you want to go back and replace these with open and closed circles, this would be open, this would be closed, but we would still shade in the middle. Yeah. So here we have a combined inequality, which is also known as an and inequality. It's a little different from the last one because there are variables on all three sides. You can only solve it as one big problem if there are variables only in the middle. So in this case, we are going to have to split it apart. We don't have a choice. You have to take it apart into two pieces. So what we do is we take the left side and the middle and write one problem out of it. 3 plus x is less than or equal to 3x plus 1. Then we just write the word and or an and sign. Then you take the middle and the right side. And we solve those two inequalities separately. And then we combine them together on a number line at the end to get a final interval of overlap. Solving the left side, I'm going to move my variables to the left. And that gives me 3 minus 2x is less than or equal to 1. Now if I subtract 3 from both sides, I have negative 2x is less than or equal to negative 2. And when I divide by negative 2, I have to remember to flip the inequality sign. So it reverses to become x is greater than or equal to positive 1. So there's part of my answer. I know that x has to be greater than or equal to positive 1. Now let's look at the other part. If I subtract 7x from both sides, that gives me negative 4x plus 1 is less than negative 2. Then we subtract 1 from both sides. And we have negative 4x is less than negative 3. Divide both sides by negative 4. Remember that when you divide by a negative, you have to reverse the inequality, so it becomes x is greater than positive 3/4. Those are the two things that are going to determine my final answer. X has to be greater than or equal to 1, and x has to be greater than 3/4. Do you notice something weird about this problem? Usually with an and inequality, we get 1 greater than, 1 less than at the end. But for this one, they both turned out to be greater than. It doesn't matter. I know that in Algebra 2, we don't give you a lot that are exceptions like this. We sort of always give you the ands that squeeze in between. That may not be the case anymore. But you still have to look at them and find the area of overlap and take that as your final answer. So let's look at those on a graph. Here's a number line. Let's let this be 0, this be 1. Then somewhere in there, I guess about here, that can be our 3/4 mark. Is that okay? Yeah. All right. Now I know that x has to be greater than or equal to 1. So it has to be this much of it. And at the same time, x has to be greater than 3/4. So that would be parentheses this way. But for my final graph and my final interval, I can only keep where they overlap. So let's kind of walk along the graph here. Do they overlap out here at negative infinity? No. So I can't use it. How about here at 0? How about at 3/4? Do they overlap there? No. Do they overlap between 3/4 and 1? No. They don't start overlapping until I reach what number? 1. Until I reach 1. And then they overlap forever. So starting at 1, there's an overlap. And you just look above it and you take whichever symbol you see. Open circle, closed circle, parenthesis, bracket. In this case, there's a bracket. So we bring the bracket down, put it on the number line. Let's go ahead and change this to another color. And then we just shade where they overlap. And you take the interval that represents that graph, and that becomes your final answer. It's only where they overlap. So we say that they overlap between 1 and positive infinity, the bracket here, and the parenthesis there. So it turned out that one of these pieces we didn't even need. The x was greater than 3/4 didn't even play a part in the final answer. We still had to check it to make sure.